Thank you very much. So like Mike said, I'm Bart. I'm from Belgium. I have been working with SQL Server for more than 20 years, and I do a lot of automation PowerShell wise, so installations, backups of databases, migrations, and so on. I try to automate as much as possible. So the session tonight goes about how the size of your character data types influences memory grants and how the SQL Server tries to save you if something goes wrong. So maybe we should start by explaining what memory grants are and when they occur. Memory grants occur during query execution and for the entire length of a query execution. So that is an important part. It's not only where the memory is needed, it is granted for the entire length of your query. And it is used for the sort operator like order by and for the hash operations. So joins of large input tables, some aggregates, distinct, union, and so on. So just to show you this, I have a few small queries. So this, I'm going to execute this on these data types 1 database. We will recreate it later on to do our demo. But just so if we take the first query, then you can see we have a simple select. And if we're going to look at the execution plan of that query, and we go to the properties, we see memory grant info, there is nothing. If we go to the second query where we do an order by, this is also a very simple query. You see here the sort operator. And then if we're going to look at the memory grant info, we see that we have a memory grant. Also, when we do distinct, we can see that we have a hash match operation. And if we go and look at the memory grants, we will see that memory is granted. So not in all cases you will see a memory grant, but you will see it if you have a sort operator or a hash operator. So I've already showed you, you can see it in your actual execution plan. So in an estimated execution plan, you won't be able to see it because your query has to have run for this information to be gathered. So, okay, when we are designing our database, sometimes we don't know how our data will look like and what the size of our column needs to be. So when we make it too small and we insert or update data, we get an error. And sometimes to avoid that, we oversize our columns. So then this looks something like this. We go to the grocery store with a large truck. So we are going to take parking space from other people and we won't be using the full potential of our truck. And that is something that we would like to avoid if possible. So like I've said before, I have prepared a demo for tonight. And for this demo, we have two databases, data types 1 and data types 2. Both have 5 tables, table 1 to table 5. And they all have a different data type. So table 1 has char 1. We go to varchar 8, 80, 800, 8000. Each table has 10 columns from 12 columns, not 10. And they all have 100,000 rows in them. Every row and every record has exactly 1 character. So in both our databases. So this is the simplest setup that I could think of to show you this. During the demo, I have made PowerShell scripts to execute this to try to avoid any failure in my demo. So fingers crossed. So during the demo, we are going to execute the same queries on every table on the two databases again. So it's a simple select star from and an order by one. So this will be the same for every column, but remember that we do have different data types. So let's get started. I will first run this script to recreate the databases that I just showed you. Okay. So this is the first part of our demo, and every demo will be approximately the same. So we are going to clear the plan cache first. Then I'm going to start a extended event session to capture the actual plans of our query executions. Then we are going to run the queries on both our databases. Here we are going to stop the extended event session again. And then I will insert the data into a database, and then we will run a query on that database and see what the result is. So let's get started with the first one. So if we look at the results here, you can see these are the queries that were on our 5 tables, and the column next to this is the requested memory. So this is the amount of memory that was requested by our query to the engine. Then in the next column, you can see the memory that was granted. Is this better like this? Okay. In the next one, you can see how much memory that was granted to the query. And then we can see the amount of memory that has been used. The last column is the number that the engine thought that was ideally for this query to run. Because my laptop doesn't have enough memory, you can see that it only requested about 1 gigabyte of memory, while ideally it thought that it would be needing 6.5 gigabyte of RAM. Now, if my hardware was big enough, and on your production server probably, this memory would have been granted to your query, which means that cached data and other query execution plans would have been evicted from the cache in order to be run this query. So this is some behavior that you don't want, especially if you see that only for the largest one, only 17 gigabytes of megabyte of memory was used. So why is this number? Where does this number come from? If you see that all the data in all the tables is the same. So the engine, prior to execution, it assumes that half of your columns is filled with data. So for this varchar 8000, it assumes that on average, each column has 4,000 bytes of data in it. In our case, we only have one character in it, so hence the large overestimation. So in order to prevent this, so lesson number 1, we should try to adapt our column length to the actual content of our data. Now, in reality, we all know that this is not always possible. So from SQL Server 2017 on, Microsoft introduced a new feature, which is called memory grant feedback. They are going to look at the previous execution of your query and then adjust the memory grant that has been done the first time we run. So for our second demo, we are going to do the same again. So without freeing the cache this time. So we're going to start the event, run the queries, stop the event, insert them into the database, and then I have an slightly other query to execute on database. So this time we are going to look at the query execution for table 5 only, but you see that something went wrong, of course. I will execute my demo again. Now run this query again. Now I'm saved. So now we see that for this query on table 5 again, the requested memory has dropped from 1000 megabyte to 30. From that 30, we see that 17 was used and the ideal memory was 30. The query or the engine determined that 30 would have been ideal. So if we're going to look at the query plan, we go to the properties and we look at the memory grant information again. Then we see another bug here, because this should be saying that it is adjusted, but it says first execution. So this is a bug. We are going to see this bug again later on. But at least we can see now that the engine saw that the first grant was excessive and it has dropped this. So for our third demo, and from this one, I'm pretty sure that I will have to run it twice because first time it will fail. We are going to free the plan cache again. So what happens if we are freeing the plan cache? We will have to create a new plan. Just to be on the safe side, I will run this script twice. Okay. And actually, it did it right from the first time, so I shouldn't have run it twice. So what do we see here? The top query is the one on the data tabs 1 database. The second one is on the data tabs 2 database. We can see, although that we have cleared the plan cache on the first database, we still have the better memory grant than on the second one. So there is one thing that I didn't tell you when I created the databases. On this one, the query store was enabled. And on this one, we had the query store turned off. So this is a new feature introduced by Microsoft in SQL Server 2022. since SQL Server 2022, they are going to write the memory ground feedback to the query store as well. So I don't know if anybody, if people know what the memory query store is or have ever seen the query store. So query store is a feature that was introduced by Microsoft in SQL 2016. And it is a place where they are storing runtime information and estimated query plans from all queries executed. Well, depends how you configure it, but from the queries that are executed on your database. Of course, we are not going to see too much information here because we only run 5 queries, but you can see information about your queries. You can see by duration, by CPU, you can go averages, maximum. So this is a really helpful tool if you are going to do some tuning job. This is something that you would really like. So in SQL 2022, Microsoft started by writing this information to the query store. So this is persisted on disk. And that's why if you are going to free your plan cache, and later on I'm going to show you, even if you are going to restart your SQL Server, that information is written to disk. So here you can see that for this node in our plan, and that should be the plan on table 5. So for node 1, which is the sort operator, it tells you that this is the ideal amount of memory, which corresponds with this 17 megabytes of RAM. So, like I just previously said, in demo 4, we are going to do the same, but we are going to restart our SQL Server before running the queries again. And as you can see in the top database with the query store enabled, we still have the correct memory ground feedback. If we look at the bottom one without the query store enabled, we have again the bad estimation. So memory ground feedback is introduced in SQL 2017, and it tries to remember the previous execution. I say tries because if the plan gets evicted from the cache, or if you restart your SQL Server, that information is lost, like we see on database 2. In SQL 2022, it is persisted on disk through the query store. The query store is enabled by default on SQL 2022 for newly created databases. If you are restoring a database from SQL 2019, 2016, then it takes the setting like it was on the original database. So if the query store was enabled over there, it will be enabled on 2022. Otherwise, you will have to enable it manually. So in this way, the feedback survives plan cache eviction or a server reboot. Does this mean that you don't have to think about your length of your data types again? No, it doesn't, because either way, for all the queries that we are seeing on our database, we are going to have that first excessive memory grant. And like always in SQL Server, if you change the slightest thing on your query, and now for this 5th and final demo, we are going to add just a simple space to our query. You will see that for the engine, this is a new query, although it's doing the same, and the result will be the same. Just the syntax that is slightly different will make sure that we have a new plan, that we have a new overestimation. So that's why it is still important. So like you can see that we have an extra space here between, and this is a new plan, which makes SQL Server granting that excessive memory again. So it is still important, although we have some mechanisms now that try to save us. So conclusions. Bear in mind that the optimizer assumes that on average your fields are filled for 50%. So hence the overestimation in this case of a memory grant. If it's filled completely all the time, we will see the opposite. Not enough memory will be granted first time, so we will be spilling to the 10 dB and to disk. Memory grants are used only for sort operators and for hash operations. A mismatch between your data and column length will waste memory. Since SQL Server 2017, we have the memory grant feedback feature who saves us based on the previous execution as long as it is in the plan cache. And since SQL 2022, that feedback is written to the query store when the query store is enabled. Like we saw in our demo, if it isn't enabled, we suffer the same problem like in 2017. And also since SQL 2022, that feedback is calculated on multiple previous executions. So not only to the last execution of your query. And the feedback survives a plan cache eviction and a server reboot. I don't know if there are any questions that I can try to answer.
I have a question.
Yes.
Is this something we need to worry about in the clouds, in the SQL Server? So if you provision a SQL cluster in Azure?
So the question is if this problem is the same in Azure as well?
I mean, in terms of the memory.
Yes. You will see the same behavior over there.
You don't have these controls because it's like more of SAS. So that's the thing about that. You don't have the server controls, so you need to be more aware, I think, how you build your database.
Yeah, but this is something that we see a lot because people, when they design the database, they don't know.
Varchar max.
Yeah. You see it a lot. Varchar max and then you go to the database and you look at the table and you see 5 characters, 10 characters, and people think, what could go wrong? Well, this could go wrong. But yeah, it's the same in Azure.